A vertical spring with a constant 5,900 newtons per meter is compressed 0.08 meters, and a 0.12 kilogram ball is placed on the top of the spring and released, launching it into the air. How far above the launch point, corresponding to the spring's free length, is the ball when it reaches 2 meters per second? That is easier than you think. So the first thing is that the energy is conserved. So in the beginning, and then the end. So in the beginning, you have potential energy due to a spring. That has to be equal to, you're going to have potential energy due to gravity based on the height, and some kinetic energy because it's moving. Okay? So what is it over here? So this is 1/2 times k times x squared. The potential energy is going to be the mass times the acceleration due to gravity times the height, plus the kinetic energy, which is 1/2 times the mass times the velocity squared. So we know what k is. So now we start plugging stuff in. So this would be, well, we could solve for h, I guess. I don't know. We'll plug the numbers in, then we'll solve. So I've got 1/2 times k, which is 5,900. Times the displacement. Now the displacement is 0.08. And that's equal to the mass of the ball times the acceleration due to gravity times the height, launching it into the air. What's the height? Do we know the? Oh no, we got to solve for the height because that's what it's asking us, right? Yeah. So we don't know what the height is, and let me move my face. Plus 1/2 times the mass again, which is 0.12, times the velocity. They're saying that it has to be 2 meters squared. Okay. So, and this needs to be squared. Let me just make sure I'm doing everything right. So let me pull up my calculator so we can plug all these in. I'll put my face here, put the calculator here. So 0.5 times 5,900 times 0.08 squared is 18.88. Yeah. And then that's equal to, calculator again, 0.12 times 9.8. So this is going to be 1.176 times 8 plus 0.5 times 0.12 times 2 squared plus 0.12, subtract the point. Wait, was that right? 0.24, yeah. So let me change that real quick.
I don't think so. No. That's really hard to do.
0.24, subtract 0.24, subtract 0.24. This is 18.64 is equal to 1.176 times age, divide by 1.176, divide by 1.176. So 18.64 divided by 1.176. So you get about 15.9. Yeah, it's not hard. It's the setup that's hard, like keeping track of what to do. And then there's no one way to, because each problem is different. So the best way to do this is just struggle with a bunch of problems, and eventually you get better at it.